continuity, just reinforcing all those topics that we've already learned. Okay. Continuity at a point. We talked a little bit about this also yesterday. How do we know if something's continuous? 3 things have to be true. The left limit, the right limit, and the actual value all have to be the same, right? So these are, so this, and this. Okay?
Wait, so like when the actual value isn't the same but the 2 limits, is that a thing? Like when the actual value isn't the same but the 2 limits are?
That would be removable discontinuity. Okay, so when the 2 limits match up but the point is somewhere else, that's still a discontinuity.
Okay.
So you have to have the left, the right, and the actual point all have to be the same. Good? Okay. All right, so let's say we have this function. We want to make it continuous. Okay. So yeah, what are we going? So we have to do. Yeah, I'm gonna write it out in notation so we can see. So let's do 2 from the left. Would be what? 2 times 2 plus 3, so that'll be 7. And from the right will be what? 2a plus 1. Yep. Now, some of you might have just recognized, oh, okay, I know I have to make those equal to each other. I'm just making sure, like, why, right? It's because you want the left and the right to be equal. So what do we get for A? 3. Now, what about the actual value, just to confirm? What's f of 2 equal to? 7. So if A was equal to 3, now are these equal to each other? Yeah. Okay. Okay, again, this is what I was just mentioning. We had already talked about. You don't need to worry about this one. So you just need to know removable. Oh, I was going to sneeze. Removable, jump, and infinite. Okay, so now we want to find the intervals of continuity and the points of discontinuity and identify each type. So we have a rational function. What's our first objective? What do we got to do? What do we call that? Factor. Okay. That's the word, the factor. Okay.
Expand.
Expand would be if you're multiplying it out.
That's what he was asking.
Factor, right?
Yeah.
Okay.
I can imagine it on my
so it's like x minus 2, and then x minus 3, and then
Good.
x minus 3, x plus 3.
Good.
So it's removable.
Good. So we have. So yeah, we can identify the different types. So we have a removable at x equals 3. And what else do we have? There's another one. Good. Good. Infinite at x equals negative 3. Okay, so this is continuous on, right? Because we also want to list, we kind of did it backwards, but that's fine. Continuous on what intervals? Negative 3 to 3 and 3 to infinity. Good. Yeah.
What does that mean?
Union.
Oh, got it.
So, when you remember when you do like compound inequalities, like you can have x is greater than 2 or x is less than negative 1. The word or is a union.
Oh, got it.
Versus if you said x is greater than negative 2 and x is less than 3, That's what we call an intersection. Because we're looking for where they overlap.
Oh,
So a union is or.
wait, but all of these.
Right,
Can
but these
exist
can't
at
overlap.
once.
It can't exist here. So it's this or
Oh.
this or this. Like if we were to put the solution, like where the possible values could be equal, you would have like open circles or whatever, right? That's how.
Like X can only, like, it would either be in
This-
this section.
Exactly.
or
It could be
section.
here, here, or here,
Yeah,
but
but not all at once.
not all at once. Yeah.
Isn't the upside down U though the same as putting the stuff in the parentheses? Not okay.
Oh, in
because
the
like
brackets.
these or brackets or whatever. Because like for
Brackets
that,
are
that x is greater than -2 and x is less than 3, you would just put that as parentheses -2, 3. Yeah.
-2 to 3. Yeah.
So that's I think we use the upside down later.
Later. Okay. Next one. Okay, we have a piecewise function. So what's the first thing?
Plug in the one, the -1.
Plug in the -1 so we can check. I'm going to write that out. X less, so just to show.
Oh, why is it limit?
Well,
Oh.
because we're going to check to see, right? We're going to check to see what happens when I plug in -1 from the left. What do I get?
Negative. No, -5.
-5. And from the right, -6. So why did I do the limits for the piecewise function? Because we want to check to see, is it removable, is it a jump, or is it it could be continuous as well. So because they're different, it has to be a jump. So this is going to be jump at x equals -1. Okay. Another piecewise function. However, we've got some interesting things going on with this piecewise function. Part of it is rational. So let's first check the limits from the left and the right. So from the left of 4 is what? 1/2. And from the right? Okay, so definitely there's a jump at x equals 4. Is that it though?
No.
We have another one. What is the other one? Good. So we also have an infinite at x equals 2. Questions? Good. So don't forget, when you have a piecewise function, we're going to check where it changes, but then we're also going to investigate if there's something else going on here. Okay, last thing for this section is, and then we'll jump to 2.4. And then I have to print out the practice. Don't let me forget. I want to give you the practice test. Okay, intermediate value theorem. Does that sound familiar at all? No? Okay. It's actually a pretty easy concept, even though the actual theorem looks weird. There's like a lot of words in here. This is really, really important. There are 4 main theorems in calculus, okay? Intermediate value theorem is one of them. So you remember theorems from geometry, all that fun stuff. Don't worry, it's not like we're going to do side angle side and all that stuff. There's only 4. There's only 4 that you need to know, okay? And you can use abbreviations. So when we get to the justifications for things later on, and when we get to like FRQs, we're not going to do that yet. Usually what I like to do is cover all the curriculum, and then we spend, we'll probably finish end of January or very beginning of February, and then we spend the rest of the time just practicing, multiple choice and free response questions. But sometimes you have to justify, right? You can't say, oh, right? Remember in geometry, we'd have your like statements and your reasons on the proofs. So you don't have to do a proof, but you have to say by intermediate value theorem, this, okay? So here's what intermediate value theorem says. You have a continuous function on a closed interval. The hypothesis is really important. I know, it's hypothesis and conclusion from, right? Remember when we had conditional statements back? So it's continuous on a closed interval. That's really, really important. If it's not continuous, we can't use this intermediate value theorem to justify anything. So they're saying, okay, you got a value here and you got a value here. So that means it's got to take on all the y values in between. It can't jump over a value. So takes on every value. Oops, what's going on here? Takes on every value between f of a and f of b. So, for example, right? Some of us drove today. Okay, you're starting from 0 miles per hour. And let's say you reach a maximum speed of 50 miles per hour. So they're saying at some point, your speedometer must read exactly 40 miles per hour, right? You can't skip over 40 miles per hour. It also has to say 41 miles per hour at some point. It has to be 30 miles per hour at some point. Could you have gone over 50 miles per hour? Not according to that, okay? So they're saying a maximum speed, but you can't like skip over a value. That's all intermediate value theorem is saying. Okay, so that's all it's saying. You just can't skip over, right? When you're driving, you can't go from 39 miles per hour to 41 miles per hour and not go 40 miles per hour at some point. Yeah.
Can I just ask a question about the graph of it?
Oh, sure.
Why aren't they including, they're only going from the end
So
points?
they're going from this point to this point. So all the values, all the y values in between, it must reach. Now, sometimes you have a graph that goes above, but if I say these are the 2 points I'm investigating, I can't guarantee that it went beyond those 2 points. It might, but all I can guarantee is that it was all the points in between. Yeah, so here's an example. We have a continuous function on the interval from -3 to 7. F of -3 equals 9, and f of 7 equals -1. Can there be a value of c on that interval such that f of c equals 0?
No. Yeah.
What do you think?
Yeah.
Yeah. If I have f of -3 is at 9, I mean, think about if you graphed this. Like, graph it. -3, 9. So I'm just going to, right, here's -3, 9. And 7, -1. Whatever. 7, -1. So I don't know what's going on with this graph. I just know those are my 2 endpoints. It could go up and down, but at some point, right, whatever, I don't know, at some point it has to cross. It has to be equal to 0. You can't go from a positive value to a negative value without it crossing 0. So, yes. Okay, so similar, or I should say, alternatively, can there be a value such that f of c equals 12? Are we guaranteed? No. We don't know, right, it's possible, but we can't know for sure.
So would you just write it down?
Yeah, so I should probably say, I should have probably phrased it, must there be a value, right? Instead of can. So it's possible, but, helps if I include the word cannot. Cannot know for sure. I think I said it, but I didn't write it down.
Wait, how do you know that? You don't know what's on the graph because it's not each.
It's not between. So here's the key. You want to look at your y values.
I didn't know if that was the given or that was a part of the question.
Oh, okay. All right, did that make sense? That's intermediate value theorem. No, that was pretty straightforward. That's the easiest one of the 4.
We just don't know that because it's not.
Don't worry, we don't get any others until I think chapter 4 is the next theorem on our list.
But like if instead of like f of c of 12, like if it said like f of c of 5, then it would be like.
Then that would be yes.
Yeah.
That would be okay, right?
Yeah. Right.
Okay, average rate of change. This should look familiar. One of the things, if there are units, I don't have units in the first one, but we do want to make sure we include units. Average rate of change is like miles per hour, feet per second, right? Meters per whatever second. And sometimes we just have a function. Okay. Are we good?
It's
X to the 2/3. Yeah, that's all it is. It's just slope. So I want to find the average rate of change. So I'm going to take 27 to the 2/3 minus 8 to the 2/3 over 27 minus 8, right? That's all. We have to do this without a calculator, though.
Oh.
What?
Wait, so that means.
Okay, so it's gonna get. Now, don't do backwards. Go like this.
Wait.
So like cube root 27 is 3.
Yeah,
Three
no,
squared.
Yeah, do the cube root. Don't square 27 and then take the
I
cube
was
root.
saying, like, whatever.
Oh, okay. I was like, wait, do the cube root. Cube root of 27 is 3. Squared is 9. Minus cube root of 8 is 2. Squared is 4. And what do we get in the denominator? 19. So our answer is
Oh, wait, no.
5/19. That's all. Remember? So just the slope. Average rate of change is just slope. Okay, good. So these two, average rate of change and the secant slope, are the same thing. Okay. So average rate of change is in reference to time. Secant slope is just in general. Okay, that's what we did. And this should look familiar as well. Tangent, what are we doing? We're taking the limit f of a plus h minus f of a over. Okay. All right. So let's find the slope of the parabola y equals x squared minus x at the point -2, 2. And then we're going to write the tangent. Okay, tangent. What do we need to write the tangent? We need a point and we have a slope. Well, we got the point. That's nice. Let's find the slope. Now, what's our value? Do you want to do the formula and then plug in -2, or are you okay if we plug in -2 right away? Do you want me to write it out? So we're going to do f of -2 plus h minus f of -2 all over h. Right?
Oh wait, why would it? Oh, got it.
Because that's our
Now
x
we're
value.
plugging it in.
Okay, and now we're going to plug it into, this is our f of x. So we have the limit, h approaches 0, so we're going to have -2 plus h squared minus -2 plus h minus, what's f of -2?
Wait, -2x squared minus x.
Oh.
Minus,
Okay, but I gave you the f of -2.
But it's not minus -2 plus h, it's a minus
Yeah.
2 squared minus.
It's okay, just like tell me I'm wrong.
Wait,
So I always plug it in last. This is like messing with my head.
F of -2, that's
can't plug it in
-2
beforehand.
squared minus.
Okay, fine, you can plug it in, you're just doing extra work.
What? How am I doing wrong?
you just need to plug -2 into f.
Are we okay with this?
Yeah.
I wrote it all out. My whole point here is this is for, wait, did I do something?
Wow, I'm really bad.
Well, I just realized that's not the right y value.
Wait, but we're not plugging in the y value.
Here,
Oh.
let's say x equals -2. Okay.
Which why we have to cross it that point?
Because I just realized if you plug in -2, you get 6, not 2. The point should have said -2, 6. There's my mistake. Did you get it?
No.
Oh, wait a second. This should be
Oh, I
Writing
plugged
the
in.
equations for them.
I plugged in the 2, so the 2, so I got -6.
-6.
Yeah.
Yeah.
So,
That's right.
oh, obviously you're supposed to do 2.
No, I realized when I was just looking
Oh.
back at it, I changed some of these problems from last year. I always go back and like revise things from year to year. And so this is a different problem than I had previously. So I changed it, but I accidentally put the wrong y value. That's all.
Wait, you're saying it'd be wrong though if you like had the wrong y value?
Yeah, I
Point
can.
slow. Come on.
Did you get slow?
I keep
Yeah,
forgetting
I
it can do points
Okay,
not
hold on.
Oh yeah.
Save your
So
time.
4 minus 4h plus h squared plus 2 minus h.
I know, it looks really
6.
good. Easy.
Right? And then we get, so all of this, the 4 plus 2, that'll all cancel.
I was
And-
supposed to get -5.
I don't know. Wait, what did you have?
Yeah.
So it should be -5.
No, you got this.
I'm going to factor out the h here. So I'll have -5 plus h all over h cancel. So you get -5.
Yeah.
Okay. So then y minus 6 equals -5 times x plus 2. There's our tangent.
Yeah.
Yeah.
The y value.
The y value is supposed to be 6.
I thought my answer was wrong because I got
Mm.
at -5.
Okay. Good. Okay, question. Oh, that's fine. That's fine.
Wait, but, sorry, I'm just, so if you did have y minus 2 equals -5 times x, how would that be wrong?
Because that point doesn't exist on that parabola.
And you just test that by plugging it in?
Yeah. Gabe, I just had a typo. That
No,
2
I
is
know.
supposed to be a 6. If it was a 2, it would not exist on the parabola. There's no point -2 on that parabola y equals x squared minus 2.
Oh wait, no, sine 0 is.
I had a different equation last year, and I changed the equation but didn't change the point properly. Okay, speed revisited. This should look familiar because it's the exact same thing as tangent slope, right? So let's find the speed. This is the last thing.
Wait, instantaneous speed?
Yes, this is instantaneous speed. So if I asked for if I asked you for the average speed, that means I need 2 different values, and then we're doing slope. If I say instantaneous speed, that means I'm using 1 point, which means I have to do the limit part. Does that make sense? Okay, so average speed uses slope, instantaneous speed uses the tangent slope. Okay. So this is our function. Now we want to find it exactly at t equals 3. How many of you are taking AP Physics besides Harrison? Okay. Oh, okay.
Yeah.
Most of you.
I
I heard,
Wait, we're all in the same class.
how does it work like, because I know that
Oh,
A
not
push,
bad.
I know A push also meets like Friday morning, so how does that like work?
there's nobody in A push in this class.
Oh, they're in the different.
They're in the other class.
But then they don't have the extra 30 minutes. That, like,
They have it on Tuesday. They have a 0 period on Tuesday.
Is it?
No. The other AP Calc class. The other AP Calc has it on Tuesday. We will need some of our 0 periods. I will, on the lesson plan, it will say 0 period.
There's
Okay.
already one that says 0.
Yeah, so next Friday, we're gonna wanna have 0 period.
I just-
Sometimes I use 0 period just for extended time on quizzes and tests, so if that's the case, you don't, the students that don't have extended time don't have to come in.
What are the units for
Oh, you know what, I didn't give, this is actually in feet, I probably should have said feet. But that's okay, I'll throw that in there. We'll use feet and we'll use seconds. Okay, so we have 16, and then we have 3 plus h squared, right? Minus 16 times 3 squared, all over h.
Are we supposed to find it without plugging in 3 first? Because it says, find the speed of the falling rock with the position roll at any time.
No, 'cause
And then it says then find what?
What? Wait, what?
Isn't plugging in 3 is wrong for this? Because it's not like
Yeah.
acid in that.
Okay, well, if I plugged in this, what does this give me? This just gives me the height of the rock, the placement. This is the placement. Y equals. Y is a Y value, right? So if I'm talking about a speed of a falling rock is 16t squared, and I just plug in 3, that's just going to tell me the height of the rock. What do I want to find? I want to find the speed that the rock is falling.
It says at any time t. And then it says.
Right. So now I want to find, right, the position, right, is the placement, the height.
Position
So they're saying,
function.
this is the speed at any time t. Now I want you to find specifically at 3 seconds.
So if it was asking for the height at t equals 3, then you could just plug in 3 and get.
16 times 9, you can just cancel them. So if you don't want to bother, 16 times 6.
Oh.
6, did you multiply it out? 96 plus 16h squared. Yeah, you'll notice right here these cancel, so I don't really. All right, so we get 96. I will call that feet per second, just. Okay?
Oh.
Because I didn't give you, normally I'd give you units, I just didn't.
Question.
Sure.
What do you do